In this recording, we're going to be graphing a basic logarithmic function. So get yourself a piece of graph paper and let's go. We're going to be considering the logarithmic function log base 3 to the x, okay? So if you recall how we pronounce such a thing, we pronounce this function y equals log base 3 of x. And we've already kind of alluded to the fact that this is the inverse of y equals 3 to the x. They have the same base. So because a log function on its own is challenging to graph, it's hard to come up with the table of values that would be appropriate. Let's instead first start with y equals 3 to the x, as the instructions say here. So let's make up a sideways table. If you want to make a vertical table, that's just fine. Let's create a table between -2 and 2 for the function y equals 3 to the x. Start with the exponential function, okay? I'd like you to fill in all those y values. Then play the recording when you're ready. Okay, so hopefully you took the time to fill in those y values. So we've got something like this. 1/8, or 1/9, 1/3, 1, 3, 9. Now, if you recall, we said an inverse is switch the x and y. So all I need to do is take the x's here and make those the y values. And I need to make the y's here into the x values. And then I can just plot those points and I've got my log graph. It's that easy. So copy in the old x's as the new y's and the old y's as the new x's. Play the recording when you're ready. Okay, so hopefully you came up with something like this. Hopefully you didn't do anything with negative signs. We don't negate anything when we find an inverse. We simply switch the x and y. Write that in your notes, please. Now it's as easy as plotting those points. So grab a pencil, make yourself an axis. If you want to emphasize the first quadrant, that's fine, kind of as I have. You're not going to need more than 3 boxes to the left or below the y or x axes. Go ahead and plot those points. Play the recording when you're ready. Okay, so hopefully you ended up with those points. I've got my green points here. That's my exponential function, 3 to the x. Familiar with that one. Turns out the log function kind of goes like this. Continues to grow as x increases. It does not touch the y-axis, just as the exponential function does not touch the x-axis. You also might notice there's a line of symmetry. Do your best to connect those green points and, in a separate curve, connect the blue points. Label each one of them. Y equals log base 3 of x, and y equals 3 to the x. Play the recording when you're ready. Hopefully you ended up with something like this. Grab a ruler or the side of a book or something to draw in a dotted line that is the fold line, the line of symmetry that would line up the green graph on top of the blue graph. That is always the line of symmetry with an inverse of a function. All right, it'd be right here. The line y equals x is the fold line. It is the line of symmetry. Let's label it. Okay, our line of symmetry in any inverse is the line y equals x. Okay, these are inverse functions. You can see this point, if I were to go right at the line of symmetry and across it, 90 degrees, go directly at it, you'd end up on the other side of a point. Pick this point, got a point. Pick this point, okay? It's the fold line, the split line. All right? We'd like to ask about the domain and range and asymptotes of these graphs. So, you've already done this work over on the left side with our exponential unit. I want you to think about how to apply that here. What would be the domain, range, and asymptote of each of those functions? You can state your answers in interval notation or in some other notation that's acceptable. Think about it. Don't play the recording till you've written down your 6 answers. Okay, so hopefully you took the time to write answers for each of those. If you haven't, please do. These are the answers. The exponential function has a domain of all real numbers. You can write it as the real number symbol or negative infinity of infinity. Its range is from 0 to infinity. And it could also be expressed in set builder notation, y greater than 0. And the asymptote is y equals 0. Over on the log function, it's the exact flip. The domain is the range from the exponential function. It just goes from 0 to infinity. Or you can write it as x greater than 0. And set builder notation would be x such that x is greater than 0. That's what the vertical bar means, such that. The range is all real numbers. And you might say, well, I don't know where it cuts off. It doesn't cut off. It just grows slowly. It continues to grow. It continues to increase as x increases. If you weren't sure, put a really big number in for x into your calculator, like 1,000,000, and see what y is. Put a bigger number. See that y continues to grow. And then finally, the asymptote is x equals 0. Does not cross the y-axis. Because what would that mean? That would mean you would allow negative values for x, and that can't make sense. There's no way to raise 3 to an exponent and have it come out negative. Right? So you can't have any x values that are the arguments of logs. Final task for you. Now that you've looked at one example, 3 to the x and its inverse, see if you can write the equation of each function's inverse below. Play the recording when you're ready. Here are your answers. If we want the inverse of f of x equals 7/3 to the x, we simply make 7/3 the base. 7/3 is the base of the exponential function. 7/3 is the base of the logarithmic function. That's why they're inverses. And again, we represent f with a -1 superscript to represent inverse of f of x. All right? No surprise then. Log base 2 of x. Log base 1/4 of x. Log base 6.2 of x. And we said we'd use our calculator to check. We could check the graphs. We could also compose these functions. Let's just take a peek at the graphs. We'll do the first one, 7/3 the x. All right, so we'll go in our y equals, clear out whatever's in there. Let's do log base 7/3 of x. And then we will do 7/3 in parentheses. Just being a little lazy not using my vertical fraction, although I do like the vertical fraction. All right, and let's check these out and make our graph. There's the inverse function, there's the logarithmic function, here's the exponential function. And if we were to graph additionally the line y equals x, it's going to look just like the fold line. Not sure what that is. There's the split line. Looks perfect. Thanks for watching.